All right, so you're probably wondering, like, well, what do I do next, right? I've got all these crazy numbers, part 4. So you remember we have this cool pattern that exists with these equilateral triangles. We've introduced this idea that we can compare a couple frequencies together to determine the difference, which is also what we can use to add to the next one to continue the pattern as much as you want. I would love to see someone go through like all the numbers, you know. It's like this is like a whole step, half step, whole step. It's this kind of has this very musical, right? Because we're dealing with frequencies, right? So you probably wonder, well shoot, let's start to compare and identify. We've identified that we can reduce the entire outside to a 3, right? Every one reduces to a 3. So let's just see 174 and 417. So we'll look at 417, which you can see our number groups here, 417, and we're going to subtract 174, and that's going to give us 243. So we know that this line here is a 243, right? But then we're just going to add 4, 5, 6, 7, 8, 9. So we can deduce now that this line here, just like this was a 3, this connection is a 9. All right, we can now compare these two. So we'll take 7, 4, 1. You love the number patterns. Minus 4, 1, 7. 3, 2, 4. 4, 5, 6, 7, 8, 9. So we can say now that this line here, we're going to make that a 9 line. and I get you can guess this one. Right, if we look at 741 and we subtract, 741, and we subtract 174, we get 5, 6, 7. It's really cool. We got kind of 2, 3, 4, 5, 6, 7, if you remember. So we get 5 plus 6 plus 7, right? 5 plus 6 plus 7. 5 plus 6 plus 7 equals 18, right? 8 plus 1 is 9. So you could see all of these make up a 9. So now you're probably asking yourself, like, whoa, does this mean I can compare every frequency to every frequency? And the answer is yes. And this is where you find the pattern. So you may end up wanting to go in this direction, where you go, you know what I'm going to do is I'm going to start to identify from, say, nodal point 528, which is our 5th nodal point. We're going to draw out, we already know that these reduce to 3, right? We know that this reduces to 3 from our earlier discussions, right? So we know that that's the 3 and a 3. So let's now see the interaction around this nonagon. If we say take 528 number group, we subtract 3, 9, or 6. 3, 9, or 6 equals 1, 3, 2. So that's 3 plus 2 is 5 plus 1 is 6. 3, 4, 5, 6, right? So we know that this line is a 3. We know that this line is a 6. Interesting. So let's compare it. If we take that trusty 528 again, and we'll subtract its family group of 285. You get 2, 4, 3, 4, 5, 6, 7, 8, 9. Interesting. All right, so this is a 9. So you could see now going this direction, 3, 6, 9. Right? Keep going. 528 minus 174 equals 3, 4, 5, or 5, 6, 7, 8, 9, 10, 11, 12. 2 plus 1 is 3. Interesting. We keep going. Right now we got to do it kind of backwards here. We're going to take 9, 6, or 3, and we're going to subtract off our 5, 2, 8. We get 4, 3, 5, 5, 6, 7, 8, 9, 10, 11, 12. 2 plus 1 is 3. So you can see 5, 2, 8 is doing an interesting interaction with this end of the spectrum, right? And then this, so if we could just imagine this as infrared, if I could break sound into, go from hertz to nanometers, and we could develop these octaves, scaling things up and down, right? But just imagine that this entry point of our visual starts here at IR, and it ends way up here in UV. Just imagine that, right? This is why we, if we were to just scale up the next scale, right? Just the repeating patterns. Anyway, let's keep going. We're going to take 852, right? We're going to subtract off our 528. Again, getting the difference. 3, 2, 4, 4, 5, 6, 7, 8, 9. Interesting. It goes back the other way. Let's bet that this is, let's say, 741 minus 528 equals 3, 4, 5, 6. So you could see, if you were to now take it to the next level and say, you know what, I'm going to draw all these points and how from the 417's perspective, right? Start to see you've got some homework to do as far as identifying the 3s, the 6s, and the 9s. I'd recommend like a color code. Oh. Get a squiggler. Lock her down. Lock down that squiggler. We'll erase that later, but you get my drift, right? So sky's the limit. Like, you want to see the pattern. Do you want to see how things move on the 3, the 6, and the 9s? Maybe you draw only the 3s. Maybe you draw only the 6s. Maybe you draw only the 9s. Different colors. Like, you want to see how energy moves. Stay tuned.